Hello everyone, welcome back to this course. In this video, we're just going to be going over the microcontroller core and its peripherals. This is for the course in microcontroller programming for power electronics, and this is like the second module basically. So here are some objectives of the talk. We'll be taking a look at the parts of the LaunchPad development kit. So last week, I put in some suggested materials to purchase, and within that was the F28379D LaunchPad. So next up, we're going to review the C28X microcontroller core processor, and then we'll highlight some important parts of the datasheet of the microcontroller. We'll be taking a look at the technical reference manual, which is a little bit different from the datasheet. It has a lot more detail. Then we'll be installing all the necessary software, or at least I'll be showing you where to install all that stuff. And then we're going to look at blinking an LED. This is the equivalent of Hello World, your first program in the embedded world is blinking an LED. Then we'll take a look at the Launchpad schematics and where they exist within C2000ware. And lastly, we'll list all our references in case you guys want to read more. So here we are on the schedule. We're in this second week. Next week, we'll be taking a look at C programming. So we'll be using this Launch XL F28379D. It's a C2000 microcontroller development kit. So this is a lot like an Arduino Mega board, if you've ever seen one of those, in that it has the microcontroller here and it breaks out a bunch of the different pins associated, with that microcontroller. So it's a easy prototype platforming board that we'll be looking at. So this specific microcontroller, this TMS 320 F28 379D, has two C28X CPUs and two control law accelerators on its core. And so that's just something that you can read up about. We'll be taking a closer look at the CPUs. The CLAs, the control law accelerators, are a bit of an advanced topic, but we'll get to it eventually. So these C28X CPUs are 32-bit processors. For those of you that have experience with Arduino, most of those are based on Atmel 8-bit processors. So these are much more powerful. And to give you some more perspective, modern computers are usually 64-bit. So these are pretty close to a regular computing platform, but for an embedded system application. So they also have a lot of math accelerators, such as these floating point units, to speed up our control algorithm. So the pins on the launch pad are multiplexed. That just means that any given pin can have various different functions. For example, these PWM channels can actually just act as regular GPIO pins, and some of them are even used specifically for serial peripheral interface communication lines. So that's just something to keep in mind when you're developing is that, these pins can have different functions. You just need to set them up properly to act as such. And we'll get into that once we get into more programming. So within each C2000 device's datasheet is a functional block diagram of the CPU and its associated peripherals. So this is an example of the TMS 320 F2837XD datasheet. So within this datasheet, somewhere here, you can actually find a functional block diagram of the entire system. And you can see all of the different buses, what these CPUs have access to in terms of controlling the different peripherals. And so that's just something to keep in mind Um, but we'll look into it in more detail later as well. So next up, the datasheet also provides a table of the pin multiplexing options. So whenever you're designing a system, obviously you'll need to know which pins go to what peripherals. And so the data sheets are a good place to look for that information, in a easy reference. This is a little bit outside of the scope of microcontroller programming, but the data sheet also has maximum ratings, which should be considered, right? So most of these digital pins, you can't apply too much negative voltage, and you certainly can't go above 4.6 volts on any of these pins, just to prevent damage to the microcontroller itself. So that's just something to keep in mind when you get to designing actual systems that use this microcontroller. But for now, we're just really looking at the basic parts of the microcontroller in this course. So now that we've discussed the board and the microcontroller to some extent, we'll be getting into the software. So first off is this Code Composer Studio. So this is the integrated development environment, or IDE, that we'll be using. So this is provided by Texas Instruments, and they recently released a new update that is built on a different kind of like back end. I think so. It used to be built on top of Eclipse, and now it's built on top of, I want to say, Visual Studio Code. So if you have experience with VS Code or those kind of environments, those kind of IDEs, then using Code Composer Studio should be somewhat familiar. But so I've linked the download to it. You just go to this page. There's an option for these download options, and then you would select your operating system, whatever you're using, and go from there. So when you run the CCS setup, you can deselect a lot of these other product families unless you plan to explore them one day. But of course, you can go back and install all of them if you need to at some point. And then we'll also need to install this C2000ware. So this is software development kit that TI provides, or SDK. And so this has a lot of the device drivers that would be otherwise kind of cumbersome to go out and develop. So they provide a lot of these libraries, a lot of these examples, which can be really helpful to jumpstart development. Um, so I'd recommend that you go off and download that. We'll be taking a look at a lot of the things that they provide in there. All right, so I mentioned that they provide a lot of these device drivers. So here's an example, of an ADC driver. Um, you would use functions within this file to drive and control the ADCs, right? Maybe you want to read the ADC. Well, they have a function that does that. You just provide the base address of the ADC within memory. And, we'll get to all how to use a lot of these later in the course. But for now, just know that it exists and we'll be using it. And so the last thing that we'll need to install is this SysConfig tool. It provides an easy way to set up peripherals. So when you get to developing somewhat complex systems, it's easy to lose track of all the different peripherals that you're setting up. And so this sysconfig tool provides an easy way to kind of like group everything together in a simple GUI environment, have everything set up in one go, pretty much. So you can install that or download that here. Um, you know, all these download pages are very similar. You just find the download options button. And so to kick things off, we'll be taking a look at this LED blink example. Um, So let me just show you. So when you open up Code Composer Studio, there is a resource explorer. Um, there's a lot of documentation, so it's easy to get lost in it. But when you open it up, if you go to View Resource Explorer, it'll take you to this page, at which point you can go to the C2000 drop-down embedded software. And so I've also downloaded these digital power and motor control kits, but we're just looking in this regular C2000 ware. English, um, I want to say devices. So you'll have to look for your specific device, right? Because all the driver code is a little bit different for each device. So we find our device, we go to driver, we go to examples, and then driver lib. We're just looking at single core processor for now, one CPU. And then there's this section for LED and LED underscore example one underscore blinky. So from here, you'll want to import this specific project, and I've already done that. So once you import it in this file explorer, you'll be able to see all the associated files within your workspace. Um, so for example, here's what that LED example one blinky.c file looks like. And I think we'll be talking about it a little bit more here. So let's go back here. So, right, all the files should show up in your workspace, and the workspace is this top left icon here. I think if you hover over it, it says Explorer, so it'll show all the different files within your workspace. And so once you plug in your Launchpad to your machine, and that's just through a USB connection to the Launchpad itself, you can either run a debug session or flash the board. So the Launchpad has a built-in debugger, JTAG, which can be really helpful for development. So we'll be playing around with the debugger quite a bit, right? So here's this debug probe. It enables this JTAG debugging. But if you were to just flash the board, then it'll program the board, with the program data that's created from that LED underscore example one underscore blinky program, and it'll basically just flash one of these LEDs on and off, I think every second. So when you first program, it'll ask you which core that you want to program it on. And so we'll just be using this CPU one. Um, and then one last thing that I wanted to mention is that TI provides the schematics for the Launchpad in the C2000ware files. And so I'd like to show you where that is if I can find it here. So we're going to go to my PC. I'm going to go to TI C2000. And I think if you go to boards, you can find it under LaunchPads. And I have this 28379D. And you can look at the schematic. And so these are, I'm not really sure which CAD tool that they've used here, but you can look at all the different schematics for all the development boards, which can be really useful, um, just when because at some point you'll turn your program into some kind of production setting, and so you won't have this launchpad completely, but you will have the microcontroller, and it can be useful to see how they use the microcontroller, just on the launchpad, so you can at least recreate what they're doing. Um, so in this case, I think I pulled up the schematic for the LEDs because that's what we were driving in this first example program. And so you can see that this red LED is connected to GPIO 34. And so it's actually, the GPIO pin's actually connected to the cathode. Um, and so it's surely an active low LED, right? So if I pull down on this GPIO 34, then the LED will start to conduct, and it'll shine a light. Likewise, this blue LED is connected to GPIO 31, and it's also going to be an active low signal that turns on the LED. So I think that's all I wanted to talk about. Here are the references. If you ever want to read more about these things, here's all the information. And I guess another thing that I should mention is that we have a website. So here's our website, and all of this material that I've shown you here is available at sites.google.com/view/dpeg. So if you go to courses, you can find the slides for the first discussion, as well as a link to this video playlist. So these will be posted on YouTube for everyone to review at their own leisure. So thanks for tuning in. I'll see you guys next week, next time.